All right, good afternoon. Today we're going to continue talking about the squeeze theorem, and we're going to do actually some trig work today. And I know that our trig skills aren't necessarily fantastic due to what happened last spring, but I'll help you out. I'll hold your hand a little bit through it. So first off, our function, x squared times cosine of 1 over x. We want to find the limit as x approaches 0. And the reason that we have to use some tricks on this one is that we can't just plug in 0. I mean, we could just plug in 0 into x, we'd be fine. Problem is, if you plug in 0 right here, we get an undefined number. That's our issue. If it wasn't for that, we wouldn't have to worry about using the squeeze theorem on a problem like this. We'd just plug 0 in for x, find out what the limit is at that particular spot. All right, so because that x looks like we're undefined, like there might be an asymptote or something at that spot, we still like to know where the graph is at, on just to the left of that and just to the right of that spot. All right, so we're going to use the squeeze theorem. All right, so we're going to take the base function here, and here's the base function, this trig function, cosine 1 over x. Well, again, if our skills were better at trig, we would all know that cosine of any angle has a minimum of -1 and a maximum of 1. And essentially, if you're looking at a graph of cosine, it's going to just flow back and forth between 1 and -1 as its height or its minimum and maximum values. So because of that, I know this, bounded by the base function. So I took the base function, cosine 1 over x, and I know its bounds. I know that it can't go any lower than -1 or any higher than 1. All right? Now, I left out the x squared part, though. All right? So now I need to get that x squared part in. So I'm going to multiply all three parts by that x squared to kind of get back to my original function in the center there. Now I can use the squeeze theorem. I can find the limit of the portion on the left, this part right here, at 0. So if I make the x as 0, that's going to be negative of 0 squared, which is the negative of 0, or 0. And then if I find the limit of the portion on the right, as x squared approaches 0, that's 0 squared, which equals 0. Since those numbers are the same, and our function is in between them, that means there's nowhere for our function to go except right in between these two zeros, which means ours is 0. So that means the limit as x approaches 0 for this ugly function, x squared times cosine of 1 over x, is really equal to 0 because of the squeeze theorem. All right, here's a picture of what that graph would look like. All right, so in blue, you see the x squared graph. That's just a basic parabola. And in red, you see the negative x squared graph. That's the upside down reverse parabola. And then the graph of x squared times cosine 1 over x is in black there. You can see that as it gets closer, since it's between the two, it's getting wedged down really, really close. And right there in the center at the origin, you can see all three dots, the red, the black, and the blue line, all cross exactly at the origin. And that's where we get this squeeze theorem. That's where the whole idea is. All right, so in your work today, I will be nice to you and I will do step 1 for you. I'll go ahead and find those boundaries, since again I know that our trig function, our trig skills are not the greatest. But you're going to be doing steps 2 and then finding out the limits on your own. All right, you know how to get a hold of me if you need help today. Again, I will be in the classroom and I will have the Zoom open. If I do not, just call me. It just means I'm sitting there and I'm paying no attention and lost track of time. So call me in the classroom, send me an email. Again, you can do that anytime during the day, to be honest. It doesn't have to be just during class time. Shoot me an email or give me a phone call and say you need to talk. All right, good luck.